one of the important concept in the DevOps is the container service. So whichever applications we have developed so far, we are going to deploy that application with the help of one of the container service software, which is known as the Docker. You can get the information about Docker from this particular given site, that is https://docs.docker.com/get started. Okay, let's see that what are the disadvantages with the traditional software deployment model. So the things are like that we require to have the physical server. Okay, so hardware is compulsory. Then the second thing is that we require to have the installation of the operating system over that hardware infrastructure. And along with that, we require additional softwares which require to run our application. Like suppose if our application is made up of that JDK or Java, Python, and Node, right? Then we require to have install all the software on our machine, right? So what are the disadvantages? Disadvantage of all these thing are like that here that the application code would be running across the hardware, right? Like there is no separate boundary, right? So here the thing is there is no separate boundary, that application is covering the whole operating system. Okay, but suppose if your hardware has multiple applications running on that, right? In that case you require the separation among the application. Okay, so there won't be any security breach. Another disadvantage of this would be that sometimes the resource may remain underutilized. Okay, so that it may happen that your application is hardly using the 25 percentage of your hardware, right? So what about remaining 75 percentage of your hardware, right? So these are the problems with the traditional software deployment model. Okay, so to overcome this, we have another model that is with the help of hypervisor. Okay, so what happens with the hypervisor, that above the operating system there would be a one more layer called hypervisor. Now this hypervisor is helpful in a such a way that it can host multiple virtual machine on it. Okay, that single virtual machine would be treated as one computer. Okay, so obviously as it is a computer, then it would be having the operating system, and above operating system you are going to have the required software like Node.js, Python, JDK, and above that you are going to have your application code. Okay, so this gives us the advantage over the previous one, that it gives the separate boundary of different application code. But here the disadvantage is that suppose if you require to upgrade the hardware or you are purchasing the new computer, right? At that time what we have to do, that you have to export the VM to a new machine. Okay, so that import and export of virtual machine is needed in this case, right? But it is not that much feasible. Why it is not feasible? Because that the size of VM is quite larger. Okay, and obviously the boundary is defined, but the disadvantage would be what, the size of virtual machine. Okay, which is really heavyweight. Why it is heavyweight? Because it install the complete operating system inside it. Okay, so that's why it is considered as an heavyweight solution. Okay, so to overcome this solution we have one more solution, that is the using a container software. Okay, right, and this is the uh, solution which is currently used in the industry. Okay, so here you can see that above the operating system you would be having one specific special software known as the container software. Okay, the feature of this container software is that it can run the individual container. Okay, and this container is nothing but it is a small operating system that you can consider. It is not heavyweight operating system, but it is a small operating system which can have the installation of the application packages that we require like Node.js, Python, and JDK, and also we can run the application code inside this particular container. Okay, so this is the lightweight solution compared to our earlier that hypervisor based solution. Okay, so The container takes the less space than the virtual machine. Also, it boots quickly and it runs in the isolation. Okay. Yeah. So the Docker is the container software, right? So what is the definition of Docker? Okay. So definition would be like this: the Docker packages software into standardized units for development, shipment, and the deployment of the application software, right? So it works like this: that above the host operating system you would be having a Docker software running, okay, and this Docker software could be having a multiple application running inside it. Okay. So all these application would be running separately from each other. Okay, that means that they are not sharing the process space, they are not sharing the file space. Okay. Now, why the Docker should be used? Because the Docker containers are everywhere. Like that, Docker is there for the Linux operating system, for the Windows operating system, even for the data center solution. The Docker is available for the cloud. Also, the Docker is available, and for also serverless. Okay, so Docker is everywhere today, right? Now, what is the architecture of the Docker? Okay, so when you will install the Docker software on your machine, at that time, there would be a client, Docker client would be running on your local host. Okay, this Docker client would be there on your local host, as well as the Docker host would also be there on your local host. Okay, so what you can say that when you install the Docker application in your computer, that means that you are running the Docker client as well as Docker host both. Okay, this Docker host is nothing but it is also known as the Docker daemon. Okay, remember this thing. So that whenever you do any operation with the Docker, at that time you initiate that operation with the Docker client, and that Docker client send that request to the Docker daemon. Okay, so these are the various commands, like you can build the Docker image, you can pull the Docker image, and you can run the Docker image. But everything would go to where? It would go to the Docker daemon. Okay, and the Docker daemon would be having various images. Images is nothing but the package software which is there inside the Docker. Okay, whenever the client will try to run the software, that software would run as a container. Okay, so that single image can be having a multiple container running on the Docker host. That depends on the requirement. Okay, container is nothing but what? It is a running software. Okay, whereas the image is what? Image is the bundled package of the software. Now there is one more thing which is known as the Docker registry. This Docker registry is responsible to maintain the bundle package of the software in it, which is known as what? Which is known as images. Okay, so the registry remains at the remote server, right, like Docker Hub. Okay, from there the Docker host can pull the images onto the local machine, and then it can run the images so that it will become a container. Okay, this is all about the Docker architecture. Now here, what we are going to do, that we are going to see the demo. Okay, in the demo, what we are going to do, that first we are going to create, or we are going to play with the Docker image of the MySQL, because if you remember our earlier project which we have developed, okay, there we require the MySQL as a database. Okay, also we are going to create the Docker image of the Spring Boot, right? And also we are going to create the Docker image of the React.js. Ultimately, we are going to have three different images, right? This is the image. This is the image of React. Okay. Here also we are going to create one more image of Spring Boot. Okay, and we are not going to create the image of the MySQL, because that MySQL image is already created on the Docker official website, and from there we are going to pull it or use it. Okay, right? So guys, let me tell you that what happens. Let me go back to the previous slide. So generally what happens, that the Docker image would be created. So you require to pull the image from the Docker registry if the image is already available. Otherwise, you have to create the Docker image. Okay. So all these things we are going to see in the upcoming video. That's it for this video.